Hello bachcho, let's read the question. The question says that two monochromatic sources of electromagnetic wave P and Q emit waves of wavelength lambda is equal to 20 meter and separated by 5 meter as shown. A, B and C are 3 points where interference of these waves is observed. If phase of a wave generated by P is ahead of wave generated by Q by pi by 2, then given intensity of both waves is I. So we have to determine which of the given options is correct. First option is phase difference of these waves at B is 180 degree. Second option is intensities at A, B and C are in the ratio 2:0:1 respectively, and intensities at A, B and C are in the ratio 1:2:0 respectively. Phase difference at A is 0 degree. So we will solve this question. First of all, we will see what will be the key concept used in the question. The key concept used in the question will be interference of waves. Now, in the question, we have been given phase of phase of wave generated by P is pi by 2 ahead of phase of wave generated by Q. So, if we write wave emitted from Q as y is equal to a sine omega t minus k xq. So, wave emitted from P will be equal to y is equal to amplitude will be same because intensities are same. So, a sine omega t minus k xp plus pi by 2 because phase is pi by 2 ahead. So, phase difference will be delta phi, that will be equal to phi of P minus phi of Q, that is omega t minus kxp plus pi by 2 minus omega t plus kxq. So that will be equal to k xq minus xp plus pi by 2. This will be phase difference, that is delta phi. Now we will see for point A. For point A, we have xq minus xp is equal to minus 5 because distance between P and Q is 5 meter. So xq minus xp will be minus 5 for point A. So delta phi will be equal to k into minus 5 plus pi by 2. Now k क्या होता है, k is equal to 2 pi by lambda. So that will be equal to 2 pi by lambda. Lambda is how much? 20 meter into minus 5 plus pi by 2, that is minus pi by 2 plus pi by 2. This is delta phi at A, which is equal to 0. So delta phi at A is equal to 0. Again, similarly, we will see for point B. For point B, we have xq minus xp is equal to 5, or delta phi for point B will be equal to k into 5 plus pi by 2, or delta phi for point B is equal to 2 pi by lambda, that is 2 pi by 20 into 5 plus pi by 2, which is equal to pi. So delta phi for B is pi. Similarly, we will see for point C, xp minus xq is equal to 0. Therefore, delta phi for point C will be equal to k into 0 plus pi by 2, that is delta phi for C will be equal to pi by 2. So intensities IA is to IB is to IC will be in ratio I plus 2 cos delta phi, that is for A it is 0, ratio I plus 2 cos delta phi. For B it is pi by 2, pi. because delta phi for B is pi, and for C similarly it will be I plus 2 cos pi by 2, that is it will be 2I, sorry, here it will also be I, it will also be I here, and here also it will be I. So that is, for here it is 4I, here it is 0, and for here it is 2I. So intensities IA is to IB is to IC will be in the ratio 2 is to 0 is to 1. So the correct answer will be option B. Intensities at A, B, C are in the ratio 2 is to 0 is to 1 respectively. Hope you all understood it well. Best of luck.